everyone. I bring greetings for NASA's Office of STEM Engagement. And I want to especially thank Pat Hines, the curator, New Mexico Space Grant Consortium, and New Mexico State University for hosting this awesome conference. It is an honor and a pleasure to be able to introduce our Acting Associate Administrator for Aeronautics. With further ado, let me read you a little of his bio. Ken Bowersox is a retired U.S. naval aviator with over 19 years of experience at NASA. He received his bachelor's degree in aerospace engineering from the U.S. Naval Academy and a master's degree in mechanical engineering from Columbia University. He was first selected to the Astronaut Corps in 1987. He has flown 5 times on NASA's space shuttle, serving as pilot, commander, and mission specialist, and once on a Russian Soyuz where he was a flight engineer upon descent. During his 5 orbital missions, he logged over 211 days in space, including 5.5 months upon the International Space Station. He was a crew member for the first 2 Hubble service missions, where he also conducted 2 United States microgravity laboratory flights. Subsequent to his mission on the ISS, he served as a director of the Johnson Space Center's Flight Crew Operations Directorate, after retiring from NASA and the U.S. Navy in 2006. After his retirement, he remained involved with the Operations Directorate. He remained involved with the Space Exploration Program as a member of numerous review boards for the ISS, Space Shuttle, and the Constellation Program. From 2009 to 2011, Bowersox was the Vice President of Astronaut Safety and Mission Assurance at SpaceX. He also lent his expertise as an independent consultant, advising clients on the management and technical aspects of aerospace projects as a member of the NASA Advisory Council and chairman of the Council's Human Exploration Operations Committee. In February 2019, he was appointed as the Deputy Associate Administrator for Human Exploration and Operations, Mission Directorate. Now he serves as the Acting Associate Administrator for the Human Exploration Mission Directorate. Without further ado, here's Mr. Ken Bowersox.
Thank you. Hey, good morning. Can you all hear me okay? Mic's hot? Great. It's really good to be here. In Las Cruces, I was just thinking, as I was looking out from the hotel parking lot, that this could be a really great place to retire if I decide to do that again. But I saw the trees, and it really is a beautiful place, and it's great to be here. I came to my first ISPCS symposium about 13 years ago, and one of the things I loved about it then was it was a great symposium to go without a tie. And I've noticed that's changed a little bit. I see a lot more ties in the audience than I think I did 13 years ago. But that's okay, it's good. But I feel comfortable without mine, and I'm happy to have left it in DC. Today I wanted to share a little bit about what we've got going on in human exploration. Next slide, let's see, is this the clicker here? Yeah. Everything we're doing in human exploration starts with this Space Policy Directive. And you can read it, but there's a lot of really important parts on it, and if you haven't read it, I encourage you to pull it out and digest it a little bit, because it'll, when people start saying you should do this or you should do that, you want to go back and look at this SPD and see how that matches. One of the things it says is that we want an innovative and sustainable program, that we want commercial and international partners. All right, and then that we want to return humans to the moon for long-term exploration and utilization. Long-term is a key part of that, followed by human missions to Mars and other destinations. So it's not just going to the moon, it's not just around the moon, it's all of that. It's low Earth orbit, it is going to the vicinity of the moon and to the surface of the moon, and then beyond, to Mars, and then beyond that someday. So why would we start at the moon if we want to get to Mars as our horizon goal? Well, for me, one of the main reasons is that we can learn and develop the skills necessary to go beyond the Earth-Moon system. But for other people, there are other reasons. That's why we have a long list here. You can take a look at the list and see what makes the most sense to you. One of the things that is key in the approach we're taking is that it all starts here at the International Space Station. This is our exploration platform in low Earth orbit right now. It's where we're developing our exploration partnerships, both international and commercial. And it's where we're learning about the effects of microgravity on long-duration missions on astronauts, the medical effects on astronauts. And we're also developing a lot of the hardware that will be useful as we go to the moon and Mars, especially life support systems, and I'll talk a little more about that. I like to remind everybody that there's a crew up in space right now. Every once in a while, people will come up to me and say, hey, when's NASA going to start its space program again? And I have to remind them, well, we have astronauts in orbit right now. We have since the year 2000. And this is the crew that's up there. They've got a very busy science program and one of the busiest EVA schedules, spacewalk schedules that we've had in a long, long time. So on the International Space Station, in order to put all the pieces together that make up the station from all the different providers, we had to have standards. Standards for the interfaces, standards for the electrical power, standard for thermal connection, standard for docking systems. So what we thought would be really important for deep space exploration was to have similar standards. And we built on the team that built the space station to assemble those standards, and all of the different space station international partners will sign off on those standards. But we didn't limit inputs to the standards to those partners. If you look, the International Deep Space Standards website is a .com website so that we could have wide inputs from all over the world, and we got inputs from all over the world. And those standards are in the sign-off cycle right now. The standards are really critical as we get out to cislunar space, and beyond. 13 years ago, we were just talking about a lot of this stuff when I was here at ISPCS. And honestly, a lot of people thought it was impossible. I heard from people over and over, there's no way this commercial thing's going to work. There's no way we can have all these vehicles. It's just too many. We can barely afford one. But look at what we've got now. We've got all these different cargo vehicles from all over the world. We've got 3 domestic cargo vehicles that are either flying now or in development. And we've got 2 commercial crew vehicles that are in development and a deep space exploration vehicle in development. So it really is amazing what we've been able to do. And this is the model that we'd like to follow out in cislunar space, to develop these multiple options with partners. So another part of our thoughts in the deep space exploration area is that when we decrease our emphasis from NASA in low Earth orbit, we'd like to see a commercial presence that fills in behind it. NASA would like to, we'd like to reduce the amount we spend is the simple way to say it, but we would like to see more activity in low Earth orbit. And the way to make that happen is to stimulate a commercial economy in low Earth orbit. And there are a lot of different activities in that area right now. We have 3 different procurements that we're working on. One for a port to set up a commercial activity there at ISS. Another for a free flyer that the draft solicitation was just released recently for people to look at and give us comments. And then we're also looking at how we stimulate demand. Additionally, we've got the ISS National Lab looking at ways to increase utilization at the International Space Station. And we've got a study going on right now taking a look at whether or not we're heading in the right direction with the ISS National Lab and whether we've got enough resources in that area. So that when NASA decides to ramp down what it's spending in low Earth orbit, that we'll have other users that are ready to step up and use the resources that are there. So if you look at it as one big integrated program, this is what you'd see. I mean, we start in low Earth orbit where we're doing development of ECLSS systems, for example, studying the effect of microgravity on the humans that are going to fly on these microgravity missions, and also developing cargo and human transportation systems. commercial capabilities that will fill in after NASA can dial down what they invest in low Earth orbit. Including the potential for a free flyer that you see there as a notional commercial platform. That might be what follows ISS. It might be something that overlaps with ISS. We'll see what the commercial industry thinks is a good idea. NASA's not mandating any solutions. We're letting commercial industry tell us what they think might work. But then once we get out to cislunar space, we want to follow that same model, right? We want to have logistics providers that have multiple deep space logistics vehicles. We want multiple landers that can go to the surface. It's the same model that we're doing in low Earth orbit, and we want to move that out. So one of the reasons the gateway is so important is because it pulls all that together. And it anchors us strategically around the moon so that we're in a convenient position to go down to the surface. At the same time, we're building our knowledge base so that we can develop Mars-class transportation. The propulsion system on the gateway, the solar electric propulsion, is what a lot of people think will be what we want to use, at least for our first missions going to Mars. And so we want a lot of runtime on that solar electric propulsion system. It's one of the reasons we want to get it up there quickly. And there is a commercial power and propulsion element being designed and built by Maxar that will get us that data, and it's working right now. And so far we have high hopes for that project and are working really well with Maxar. So in addition to the commercial aspects, and down where it says cargo, you could almost say commercial, because most of those elements are what we consider more commercial fixed price procurements, but they go up from Earth as cargo, either on commercial launch vehicles or they could go up on an SLS. We've had a lot of people suggest that, but right now we don't think we've got the production rate to do that, especially in the early days. When we start going to Mars, that might be something we do when we have to launch more elements that are bigger. But for now, we think it's a great way to provide a place for our commercial partners to participate. And so, again, where it says cargo, landers, and gateway elements, think commercial launch vehicles. And then on the crew side, the only vehicle we have right now in our plans is the SLS that can lift Orion, and that's our only deep space vehicle that we think we'll have out in 24 or 25. And so that's our plan for crew. And this is how it all comes together. Sometime late next year, middle of the year after, but we're getting closer as we talk. The first uncrewed Orion will be launched out around the moon. Then a couple years after that, we'll launch the first humans out around the moon on Artemis II. Right about the same time, the power propulsion element for the gateway should arrive on orbit, and then the logistics, and we were calling it logistics for a while. We're calling it HALO now, but it's a small habitation and logistics capability that mounts on the front of the PPE. That's our minimum gateway configuration to support the lunar landing plans. Then eventually the landers start to aggregate out there, preparing for the crew to arrive, and out in 2024, if resources come along, then the Orion will arrive with crew. They'll go into the lander and come down to the surface. And while all that activity in the upper swoosh is going on, the Science Mission Directorate is running a lot of different activities to bring small payloads to the lunar surface, commercial lunar payload services, and hopefully a large-scale cargo lander that we can use to bring down habitation elements, rovers, things that the crew would use in addition to the equipment they'll bring with them on their lander. So this is sort of the heart of the Artemis program from now to 2024. I want to go into a little more depth on Gateway. Unless you really take a close look, Gateway can look like extra work on your way to the moon, all right? Number one, it's supposed to be extra work on the way to the moon because it's got an additional mission. It is building capability to go to Mars, right? It's allowing us to do Moon and Mars at the same time. It allows us to have better feed forward on all the work that we do around the Moon to our Mars mission. It also allows us to bring up commercial logistics services and start that commercial activity in cislunar space. If we think of the Gateway as an additional source of electric power, propulsion, attitude control, you can see that it can provide resources to not only logistics vehicles, but also to the lander. But what I want you to look really close at is the size of that lander. You know, it's bigger than the Gateway. We're not talking something that's as large as the International Space Station. Now, this lander system that you see here is a NASA concept that we use to evaluate the feasibility of the whole concept, the whole idea. And we have a procurement going on right now where I think that's probably where a lot of people are this year that might have been here at this symposium. They're off working on human landing system procurement proposals. When we see what those guys bring back to us, what those teams bring back to us, then we'll feed that back into our plans and we'll use that to tailor those plans. And you may see some adjustments then. But what you get at the Gateway with this minimum capability is the ability to control attitude without using propulsion. There's reaction wheels on the power propulsion element. You get the chance to test the solar electric propulsion. And there's an opportunity to store and transfer logistics, which could be really useful if you start to run into weight issues with your lander elements. You can offload some of the contents of the vehicles over to a logistics vehicle, allows you to split it up in a convenient way, and then meet with that logistics vehicle out in cislunar space and transfer everything over to the landing vehicles. So basically what you have here is 3 docking ports that we can use for a really long time that we don't have to throw away. And that's the minimum Gateway. Where we do more is when we start talking international partnerships. The first international partnership that is critical is the European Service Module, and that's on the back of the Orion. The European Service Module is part of a barter arrangement that's actually very complex. It includes some of the commitments that we've got with Space Station, along with commitments in cislunar space. And it actually hinges on the Gateway. So something that we're working with our European partners is to help them understand that we're committed to Gateway so that when their elements arrive, we really will want them and have an opportunity to use them because they're part of the package that has to be approved by our European partners in order to get the 3rd European Service Module, which is critical for Artemis 3. What's been amazing to me as I dig into all this is just how complicated all the arrangements are. But I'm starting to love complicated. I realize that complicated sometimes means that you increase resilience, you build support. And it is a lot more complicated than what we did with Apollo, but it's on purpose. Well, and when I get into some of those discussions where I'm trying to explain to people why we're doing things one way or the other, it really helps to remind myself that we are so close to going to Mars. I mean, this picture here is from one of the rovers that was is up there working now. And, you know, it's a picture looking back at Earth. And I think about astronauts walking on the surface and seeing that view. We've managed to do it with robotic spacecraft. We are, I would say, within 20 years, within one generation, if we want to be, of doing it with humans. Now, you have to balance the technical requirements, the risk, the financial aspects. All those things have to come together in the right way before we'll be able to do it. But when I see this picture, it reminds me that we're close. and that I might actually see it someday when I'm retired over here in Las Cruces. All right, so that's all I have, and I'd love to answer any questions that you might have for me.
So, well, we have a lot of questions.
A lot of questions? Good.
The audience has been very, I wanted to point out, if you haven't looked at the back of your program, there's a picture of Ken here. I won't say how many years ago, but, you know, he was here.
I was much younger.
Different organization.
Same amount of hair, though.
Yes. We're all working very hard to try to increase the amount of hair that we have. So, the number one question, this is going to be very indicative of the type of conference this is and what the people are interested in, is, are space tourists considered crew or cargo? That's the question.
Cargo.
Cargo. All right.
No, the space tourists that we've flown before, we don't call them space tourists, we call them space flight participants. They've been really active members of the crew, and I anticipate that type of relationship going forward. It's really been, they've brought great enthusiasm to their visits to ISS, and I think it'll be great to have more of those folks. And I look forward to seeing someday when that first space flight participant goes around the moon or to the lunar surface.
You just had a UAE guy on the space station, so that was the first for that nation.
And it was so neat down at Baikonur for that launch to see all the people from UAE. They were so excited to have their first astronaut go into space, and they want to have more.
Good. Okay. Let's see. Why is NASA not using SLS for launching all the elements of the HLS?
Well, that's a great question, and I get asked a lot. Part of the reason is that it's just not looking likely that we could get the number of core stages required in order to meet our 2024 goal, and we don't want to slide anymore. But another reason is to allow commercial participation. We think it's a good way to infuse some commercial competition, some commercial spirit into the whole program, and build that base of support that we need to go to the moon and to Mars.
Are there commercial reasons to go to Mars?
I don't know of a commercial reason to go to Mars yet, but I still want to go. And I think there's probably a lot of other people that share that spirit. When I look around and talk to people, they just assume that that's the reason we would go. So a direct commercial reason I can't find. Now, an indirect commercial reason, I talk to people all over the world that remember how the United States of America did Apollo, and they remember us for that, and they think a lot of our country for that. When they buy American products, they think about the country that sent people to the moon and think, well, that must be a good product. Those people can send things to the moon. And I think we'll see a similar effect with sending people to Mars.
Several people voted for this question. 2024 is a bold target. What changes are being made to NASA acquisition strategy and procurement methodologies to support that date?
Well, when we had the acceleration directive, the first thing we did was to think about what we had to adjust in our own system. And we realized that we had a procurement mechanism already set up that we could just accelerate, and that was the broad area announcements, the next step broad area announcements. And so we have used that particular mechanism with adjustments for things like intellectual property and the requirements that we put on each individual appendix, and it's been very, very useful.
Good. Are there key components, or the question actually is, what key components in exploration vehicles do you believe should be standardized?
Well, I think when you talk standardization, the big thing is interfaces. That's where you need those standards. So things like the electrical power connections at the docking ports, the voltage of the electrical power systems, just the actual mechanical interface of the docking ports so that one vehicle can dock with another vehicle. I think those are the critical items. But then something else that's really important is if you want to do refueling, it's important to have standards on the connectors for refueling and the types of fuels that you use. And I think that using refueling out there in cislunar is going to be terribly important to make our program sustainable.
Okay, well, here's an interesting question for you. What is the status of hiring a permanent AA for HEO, and are you interested in the job?
Well, if I wasn't interested in the job, I wouldn't still be here as the acting, right? So I'd be happy to serve in the position. But I know our administrator is looking for candidates, and there are a lot of good people out there that have expressed interest. When I was asked this question by Congress recently, I said that it was likely by the end of the year that we'd see a named AA for the Human Exploration and Operations and Mission Directorate. After that, I was asked to dial that back a little bit and make it a few weeks. So now what I say is somewhere between a few weeks and a few months. But I know our folks are looking really hard, but hires like that don't happen fast, and my honest desire is that they find the right candidate that can work well with the whole team on the 9th floor of the NASA headquarters building, and we want to take the time to find that correct candidate. So we want to make sure we give them as much time as they need.
We get some very interesting questions here, Ken.
Wayne, you're asking me hard questions.
No, this is the crowd. This is not Wayne. This is the crowd. So, and they're popping in here faster than I can keep up with them. Will HLS bidders be required to show credible cost, or will NASA, where'd it go? Will NASA be willing to accept the deliberately below-cost bid by a billionaire who doesn't need to make a profit? That's a hard ball.
Well, that's a tough question. I'm trying to decide if I can even say anything since we're in the process of doing the procurement. All I should probably say is we look very carefully, we consider everything, and we try to be realistic in when we make awards. I probably shouldn't say much more than that.
Okay. Can commercial crew vehicles be ready in time to support the ISS before we lose Soyuz access? And are there any talks about buying more Soyuz seats?
Well, so let's talk Soyuz status. Right now, we're covered with Soyuz seats out till the fall of next year. Okay, so if we go through past the fall of next year with commercial crew, that's when we would have to look at another way to get another seat with our Russian partners, and we need to start earlier. So we're discussing that with the folks inside government here in the U.S. and with our Russian partners. But we don't have any agreements that are concluded yet. But our desire is to have a U.S. crewman flying on every Soyuz from now on through the life of the station, because it makes it really convenient for crew rotations to rotate the same crews, always having a U.S. crew member on board. The difference will be where we transition from compensating our Russian partners for carrying a crew person to trading seats with our Russian partners. And that depends on when we reach operational capability, and I use the word operational loosely, where we're ready to fly Russian crew members on the commercial crew vehicles. And it is likely that we'll want to try and set up an arrangements for at least one more seat on the Soyuz, from fall of 2020 to spring of 2021.
Here's an interesting question. When will you set a new firm launch date for Artemis 1?
Well, the administration answer for that is when we name a new AA, we're going to give that person a chance to look at all of the schedule analyses that have been done and let them re-baseline the date and cost information for Orion and Ares 1. But of course, we've got schedules that we're working to now. You have to have a schedule to work to. The schedule that we're managing to is very, very aggressive. What it shows right now is having the core stage finished here around the end of the year, and then shipped over to Stennis for testing. The testing at Stennis we expect to be somewhere between, in the best case, it's going to be 5 or 6 months. But then there's risks like weather And then we don't know how much refurbishment we might need to do to the stage after we've run those engines for a full flight duration in the test stand. So we're conservatively thinking we could take an extra couple of months to do some of that work, but then some of that work could be done at Kennedy Space Center, right? There's a lot of judgment involved in trying to put the schedule windage on that whole problem. But in the very best case, we have a chance to actually have a rocket on the pad and launch by the end of next year. But when you start throwing all those different uncertainties, it's more likely that we move out into 2021. But we want to let the named AA come in, take a really close look at the schedule, and then commit to Congress on what our best launch date would be.
Okay, well, Ken, I think you're going to get the award. We are out of time for questions.
All right.
And
great.
we have a whole bunch more here. You're going to get the award for most popular guy in terms of the numbers of questions asked.
Well, thanks for all the questions.
And I'm going to go one more because we're out of time, but I control the trapdoor, so we won't go. This, I think, is a question you ought to answer. Do you believe that members of Generation Z will be able to go to Mars in their lifetime?
I think if they want to go and they work it with all their peers and build that support, I think we'll see it.
Thank you very much, Ken Bowersox.